In this movie, I'll look at two traditional pencil and paper methods of division called short division and long division. Use short division when the numbers are simple. For bigger numbers, use long division. Here's a simple example of short division. 258 divided by 7. As you'll see shortly, it's going to really test my grasp of the 7 times tables. Start by writing down the 258 and draw two lines, one below and one to the left, like this. The 7 goes here. Step 1, 7 divided into 2. This doesn't go, so try 7 into 25. Well, 7 4s are 28. That's too big. 7 3s are 21, and that would give a remainder of 4. So write the 3 below and carry the remainder 4 along to join the 8. And finally, 7 into 48. Well, 7 6s are 42, so 7 into 48 goes 6 times with a remainder 6. And that's the answer using short division. 36 remainder 6. At this point, I'd like to say something about the terminology I've been using to describe this calculation. In particular, how I've been referring to the place value of each digit, that is, whether they're hundreds, tens, or units. The first division I described was 7 into 25. A student recently said to me, "But that's not 25, it's really 2 hundreds and 5 tens, so you're actually dividing into 250. Well, this is a good point. However, you need to remember that short division is just a technique for doing a calculation. It makes life easier to ignore the place value of these numbers while you're doing each part of the calculation. But as long as the numbers are written down into the correct columns, that is, hundreds, tens, and units, their place value will look after itself in the calculation. And now, long division. These numbers are really too easy to justify using the more complicated long division procedure, but I will use them just to demonstrate the method, and also so you can see that the two methods are basically the same. They're just set out differently. So this time, the horizontal line is above the number. As before, 7 doesn't go into 2, so 7 into 25. This goes 3 times. Now I need to work out the remainder. 3 7s are 21. Put the 21 here, subtract, and there's the remainder 4. Bring down the next figure, the 8. 7 into 48 will go 6 times. Multiply the 6 and the 7, 42, subtract, and there's the final remainder, 6. As before, there are two parts to the answer. The whole number part, called the quotient, is here, and that's 36, and the remainder is here, 6. And now I'll tackle a harder example using long multiplication. This time it's 958 divided by 27. I was okay on my 7 times tables, but like most people, I don't know my 27 times tables. You should be able to see that this layout really helps with these harder calculations when I'm finding the remainders at each step. 27 doesn't go into 9, so 27 into 95. Now it could be 3 or maybe 4. If you aren't sure, try out the possibilities in rough notes. For example, 27 times 4 gives 108. That's bigger than 95, so I need to try a smaller number. It must be 3 times, so put the 3 here. Now multiply these two numbers. 3 times 27 is 81. and as before, I find the remainder by subtraction. That's 14. Bring down the next figure, the 8, and now 27 into 148. 5 looks plausible, so I write the 5 here. And now to find the remainder. Multiply these two numbers. 5 times 27 is 135. Subtract these two numbers, and my final remainder is 13. So there's the answer. Using long division, 958 divided by 27 is 35, remainder 13.